Now, alkenes can be oxidized when they react with hot concentrated acidified KMnO4. So, uh, in this video, we are going to look at how to predict, okay, or how to get the products of reaction between alkenes and hot concentrated acidified KMnO4. I'm going to give a few examples, okay, different types of alkene. Now, the first one will be alkene with a double bond. Okay, then we have two carbon sharing the double bonds, and the carbon on the left hand side. Okay, this example, it is bonded to two hydrogen. Right hand side, okay, I'll just put two alkyl group, CH3. Now, when it is oxidized by hot and concentrated acidified KMnO4, what do? Is we are going to split this compound from the center of this alkene, which is from the double bond. So the left hand side, the carbon that is bonded to two hydrogen, okay, will become CO2. The 2H will form water, okay, with the O from this oxidizing agent. The carbon on the right hand side, okay, with the double bond, let's add an O to the double bond and copy the two CH3 groups that's bonded to the carbon initially. Now, this is a ketone. It will not be further oxidized by acidified KMnO4. So at the end, we get only one organic compound in the products, which is a ketone. This is a propanol. And the other carbon will form CO2 because it was bonded to two hydrogen. Now, if we have to balance the number of oxygen from this equation, at the end, okay, we added one O, okay, the second oxygen to the two hydrogen to form water, and two more oxygen to form carbon dioxide. So altogether, four hydrogen was obtained from KMnO4. Now, let's look at the other example. This time, again, an alkene, two carbons sharing the double bond. So this time, the carbon on the left-hand side, okay, I still put two CH3 groups. And the one on the right-hand side, I would like to change a little bit. One of them is hydrogen, another one is CH3. Okay. Now again, when alkene reacts with hot concentrated acidified KMnO4, okay, we have the compound from double bond. So the left-hand side carbon bonded to two alkyl groups. Okay. So add an oxygen to the double bond. Then the C, the carbon, is also bonded to two CH3 groups. Now again, this is a propanol, which cannot be further oxidized by acidified KMnO4. So this is one of our products. Now another one will be from the right hand side half of the compound. So again, write the C with the double bond, add an oxygen. Now this C is bonded to one H and one CH3. So if you can recognize this is an aldehyde because of the C double bond O, the carbonyl functional group, and with an H. So this is an ethanol. Now, this ethanol will not stay as the final product because aldehyde can be easily oxidized by acidified KMnO4. Okay, because this KMnO4 is a very strong oxidizing agent. So this ethanol will be further oxidized to carboxylic acid. So we have to change this H to OH. CH3 will remain the same. So this is an ethanoic acid. Now in the exam, they will normally ask you to draw the products, the final products. So we do not need to go through this step by writing down the ethanol. We can go straight to the final product. So you only have to write propanol and ethanoic acid as the final products of this reaction. So when we cancel this, okay, so bear in mind, if you see a H bonded to the C double bond O, it is an aldehyde. It can be further oxidized to a carboxylic acid. Okay, now let's balance the equation to find out how many number of oxygen was used, okay, from the oxidizing agent to get these two products. So 1O, 2, 3. So to balance this equation, okay, put a 3 in front of the square bracket oxygen to show how many oxygen were obtained from the oxidizing agent to form the products, because this is an oxidation reaction. Right, let's recap a little bit. So if you see carbon bonded to 2 hydrogen, the product will be CO2 and water. Now if you see the carbon bonded to 2 alkyl groups, you will get a ketone as the product. Now if one of them is hydrogen, right, at the end you become OH. So basically in the products, okay, CO2, the ketone, and also ethanoic acid, none of the C double bond O carbon is bonded to hydrogen anymore. So after you have solved your question, you found the answer, please check again if you find any C bonded to hydrogen, then you might want to uh, re reconsider your answer and check again, okay, which part went wrong. So that will be predicting products in the reaction of alkenes with hot concentrated acidified KMnO4.